Ahoy, ye landlubbers! We're about to embark on one of the most challenging topics of the whole time, but it's piece by piece. If you can do each piece, you can do the whole thing. If not, we may have to make you walk the plank, so be careful here. Let's take a look at two challenging questions from the book. Here's the first question: solving rational equations when we have common denominators. When we don't have common denominators, that's the first thing we have to get. So, step 1, restrictions. We can't have 2x plus 6 equaling 0. X cannot be negative 3 based on this part of the equation. Based on this part of the equation, x cannot be negative 4. So there are your restrictions. There's too much writing in this question for me to do it by hand. It would get very messy with this little pen on my tablet. So we'll go piece by piece. Step 1, always is factor your denominators in order to find a common denominator that will work. And you also notice from here it's a little easier to see that the x can't be negative 3 and the x can't be negative 4. But that tells us that in our common denominator, we do need a factor of 2. We do need a factor of x plus 3. Here's a factor of 2. We've already got that covered. We need a factor of 3, and we need a factor of x plus 4. Going to go two different ways at this. That's only a 1. Two different ways at this. We're going to look, and we're going to see what happens here. The book's way is to multiply everything by your common denominator. The book's way is to multiply everything by the common factor and then see how things cancel out. Another way to do this slightly different is to get it all over a common denominator, and then that common denominator can go away. Mathematically, they are equivalent. Work whichever method works better for you. We'll do this way first, and we'll do the common denominator way the second time. So in this case, we have that our common denominator has to have a 2, an x plus 3, a 3, and a x plus 4 in it. So you multiply everybody by that. 2 times 3 times x plus 3 times x plus 4 times this term. 2 times 3 times x plus 3 times x plus 4 times the 1/6 term. 2 times 3 times x plus 3 times x plus 4 times this term. And now you can simplify a couple of things. Some stuff will vanish. You'll notice there's an x plus 3 here. That'll go away. There's a 2 down here. That will go away. On this side, the 2 and the 3 will cancel the 2 and the 3, but both of the x terms will be left. Oh, we're going to have a quadratic there again. X plus 4 cancels an x plus 4. There we go. They cancel. What's left on this side is 5 times x plus 4, and then an x plus 3 and an x plus 4. And then 2 and 3 are left here, and the x plus 3 and the 2. So lots of pieces. Do a lot of simplifying. Well, the distribution here, 15x plus 60, expanding those, x squared plus 7x plus 12, that whole thing is subtracted. Be careful when you do the subtraction, that's a minus. Here, 2 times 3 times 2 ended up being 12, 12x plus 36. Move everything to one side because it's quadratic. You need to set it equal to 0 to make it work. And once you have that quadratic, that factors nicely into x plus 6 and x minus 2, giving you x is either negative 6 or x is 2. Double checking your restrictions. X equals negative 6 and x equals 2 are both legitimate answers. Yay. Method 2. Very similar. Start out by identifying your restrictions. Factoring and identify the restrictions. X cannot be negative 3. X cannot be negative 4. Step 2 is slightly different. You just get everybody over a common denominator. This term already had a 2 and an x plus 3 in the denominator, but you needed a 3 and an x plus 4. This term had the 2 and 3. You needed the x plus 3 and the x plus 4. This term only had the x plus 4, so you need 2 and 3 and the x plus 3. So now you notice everybody has the common denominator. Here's the thing. As long as you have identified your restrictions, we all have the same common denominator. 2 times 3 times x plus 3 times x plus 4. And as long as you have identified your restrictions, it can just go away. Because if you have 2 over 5 equals x over 5, that's just 2 equals x. Things like that. If the denominator is the same, basically what you're doing is multiplying through by it, which is what the previous method was. It's just how you think about it. Multiply through Make the denominator go away. That looks familiar. We've seen it before. It's 15x plus 60 minus the x squared plus 7x plus 12 equals 12x plus 36. Works out to x equals negative 6 or x equals 2, the exact same solution. And again, check the restrictions and we are okay. Good. Whew. That's a tough one. Why are we doing all this work with the restrictions? Just checking. Take a look at this one. This is going to be a little twisted piece. From page 499, 56 over x squared minus 2x minus 50 minus 6 over x plus 3 equals 7 over x minus 5. Step 1. What do we have? We factor and we identify our restrictions. Restrictions here are that x cannot be negative 3 and x cannot be 5. There we go. All right, there's your common denominator. Method 1, working our way through, multiplying through by the common denominator. Multiply both sides by x plus 3 times x minus 5. In this case, on the left-hand side, give me a nice color, thank you. The x plus 3 cancels the x plus 3. The x minus 5 cancels the x minus 5. The second term, x plus 3 and x plus 3 cancel this term. Those cancel. And you are left with 56 is the only thing left from this side. 6 times x minus 5 in the second term. And on the right-hand side of the equation, 7 times x plus 3. No squares here. A lovely linear equation, which divides out to 65 equals 13x, or x equals 5. And so we're very happy we have a nice simple solution. But ahoy! There's a problem. X equals 5 was a restriction. We said x cannot equal 5, and we got x equals 5. This is a contradiction. There is no solution. And it's such a bad idea that it was even written in the dreaded Comic Sans. Ooh, no solution. You always have to check your restrictions. It's called an extraneous solution. You have a solution, but it's not an actual legitimate solution. We can take a look at the graph in a moment and see, but just let's walk through a second way to do it. If you're all right, hello. There we go. Again, start out by factoring. Write your restrictions. X cannot be 3, negative 3, and x cannot be 5. Get your common denominator. We already have the x plus 3 and x plus 5 together on the 56. The second term requires an x minus 5. The third term, the term on the right-hand side, requires the x plus 3. Linear equations, solve it down. X is 5. It's the same thing. And once you get to this point on both of them, it's always the same. So it's all good. And again, we have x equals 5, but we were restricting it. X cannot be 5. No solution. See, take a look just quickly at what those two look like, because it's kind of curious. The first one with two solutions is very interesting. It takes a look. These are not something that you would be expected to do on any sort of quiz or thing like that. But if you like to think graphically, you're welcome to think graphically this way. Take a look and see what happens, where things intersect. It can be a little confusing if you have issues with it, but let's take a look. Here's the first equation. Whoops. There's the first equation. Come on. There's the first equation. Stay there, you landlubber. And here's the asymptote. X cannot be negative 3. The right-hand side of the equation was 2 over x plus 4. And lo and behold, it's got its asymptote. Lo and behold, there are two places where they intersect. They intersect at negative 6 when x is negative 6. Y is 1, but that doesn't have any meaning in the original question. X is negative 6, and they intersect at x equals 2, which was indeed the set of equations that we found. The very last one with no solution, it's kind of a mess. Here's the left-hand side of the equation, two asymptotes at negative 3 and 5, because there are two factors in the denominator. The right-hand side of the equation looks like such. And you see that it comes tucking in, but never quite reaches the red one. You can sort of see that red pixel still to the left of the blue pixel over here. And on this side, the red pixel still to the left of the blue pixel. They're very close, but they never meet. And If they did meet, it would be at x equals 5, which we already said was not okay. So there you go. There's your lovely answers. A good challenge today. Have a lovely day, a lovely Tuesday, if I can ever end the